Today we have a situation based on gravitation, and in the scenario today we are given a particle of mass small m, which is situated at a distance at a height small h from the surface of the earth of mass m and radius capital R. And we are to find the velocity v such that the particle is tangentially grazing the surface of the earth at the diametrically opposite end B, right? So in order to find V in terms of the specifications of the planet, that is M or R or small h, we'll have to first find the relation between velocity V and velocity V1. That can easily be evaluated by conserving the angular momentum L, since the torque in the entire system is zero, right? So we have the first thing over here which we'll be doing, and then the next will be conserving the energy. Work done by any of the non-conservative forces is zero. Now, through the first thing we'll be doing will be conserving the angular momentum, and by conserving the angular momentum we get mass times velocity times the lever arm. The lever arm is basically the distance we have, is going to be r plus small h for the position initially, right? And for the final position it is going to be m times v1 times r, since r is the lever arm over here. Okay, so we have this equation and m cancels away, so we have the relation between v and v1 as v1 is equals to v times r plus h over r, right? So we have this little relation between v1 and v. This relation we'll be using in the conservation of energy thing, right? So for the conservation of energy part, we have the final kinetic energy as half m v1 squared minus the initial kinetic energy for the same particle of mass small m is going to be half m v squared. Potential energy is going to be g m over capital R minus the initial one is going to be g m over r plus h, right? The entire expression will be equated to 0. And now solving for the relation half v squared r plus h squared by r squared minus 1 is equals to g m times 1 by r minus 1 by r plus h, right? So we have this thing, this equation then further resolves. Now solving for the value of small v, we get obviously a root. We get root 2g mr over r plus h times h plus 2r. So we now have the answer to the situation we had, and that brings us to the end of the question. Thank you for your time.